Every building stands on a foundation. But did you know that not all buildings use the same type of footing? A small house, a multi-story building, and a bridge may all use completely different footings. So how do engineers decide which footing to use? What happens if the wrong footing is selected? Welcome to Civil Sprint. In today's video, we'll explore the different types of footings used in civil engineering, understand their applications, and learn why choosing the right footing is essential for the safety and stability of any structure. Let's get started.
What is a footing? A footing is the lowest part of a foundation that transfers the load of a structure safely to the soil. Its main purpose is to distribute the load over a larger area and prevent excessive settlement. A properly designed footing ensures that the building remains stable throughout its life. The type of footing selected depends on factors such as soil-bearing capacity, structural load, groundwater conditions, and site constraints. Let's now look at the major types of footings used in civil engineering.
1. Isolated footing. The isolated footing is the most commonly used type of footing. It supports a single column and transfers its load directly to the soil. These footings are usually square, rectangular, or circular in shape. They are economical and are commonly used in residential and small commercial buildings where soil conditions are good. 2. Combined footing. When two columns are located close to each other, separate footings may overlap. In such situations, engineers provide a combined footing. A combined footing supports two or more columns using a single footing. It helps distribute the load uniformly and is often used near property boundaries. 3. Strap footing. A strap footing consists of two isolated footings connected by a rigid beam called a strap beam. This type of footing is used when a column is located near the edge of a property and a symmetrical footing cannot be provided. The strap beam helps balance the load between the columns. 4. Raft or mat footing. Imagine constructing a building on weak soil. Providing separate footings for every column may not be practical. In such cases, engineers use a raft footing. A raft footing covers the entire area beneath the building and supports all columns and walls together. Because it spreads the load over a large area, it reduces settlement and improves stability. Raft foundations are commonly used for heavy structures and poor soil conditions. 5. Pile cap footing. Sometimes the upper soil layers are too weak to support a structure. In such cases, loads must be transferred to deeper, stronger soil layers. This is achieved using piles. A pile cap is constructed on top of a group of piles to distribute the load from the structure. Pile cap footings are commonly used in bridges, high-rise buildings, and large infrastructure projects. Conclusion. So, whether it's a small house, a commercial building, or a massive bridge, every structure depends on the right type of footing. The selection of footing depends on soil conditions, structural loads, and construction requirements. A well-designed footing ensures safety, stability, and durability for many years. Thank you for watching. If you found this video helpful, don't forget to like, share, and subscribe to Civil Sprint for more civil engineering concepts and